Am I audible? Am I audible, Sachi?
Yes, sir. Yes, sir.
Yes,
You
sir.
are audible.
Hello. Good afternoon, all. Am I audible?
Yes, Mr. Lenka, you are audible.
Yeah,
Uh,
thanks.
Sachi,
Thanks.
your
yeah,
voice is
okay.
very slow. I cannot hear you properly.
Uh, sir, whose voice?
Hello.
Yes, sir. Sir, you are audible.
Now audible. Yeah.
Yeah, okay.
Sudhendu sir, namaste.
Namaste, sir. Namaste.
How are you, sir?
I'm fine. I'm fine, actually. I'm good. How are you, sir?
I am fine, sir. So
Okay.
thank you for accepting our invitation. Sir, we are organizing such kind of webinar as a part of our webinar series for the students and aspirants who wishing to make their career in this field. And
Yes.
we are inviting an experts from the industries like you. And though we are teaching theoretical perspective in our classroom, we are looking for some, practical aspects in the classroom.
Okay. Okay.
Normally, every year we are scheduling this kind of seminar, or not a seminar, but an expert sessions in our classroom, physical one-to-one session.
Okay. Okay.
But due to this corona pandemic, this is not happening, sir.
True. True.
So
True.
still we have not left expectations, and we are not left behind our efforts. So we are putting our efforts. Professor Sachi, Professor Umang, Professor Vipul Joshi, they are all putting
Yes.
their efforts for organizing such webinar. So students will get a contemporary knowledge of the field.
Yeah.
So
Definitely. Definitely.
official session would be commenced by Professor Sachi, but just off the record, sir, thank you very much for accepting our invitation, sir, and thank you very much for sharing your expertise with our students, sir. Thank
Thank
you
you.
for
Thank
accepting
you,
our
sir.
invitation, sir. Yeah, Professor Sachi, can we officially start the session?
Yes, sir, definitely.
Yeah, you may go ahead, please. Sir, shall we
Okay.
start, sir?
Yeah. Sure. Sure. Absolutely.
Sure. Thank you, sir.
Yeah.
Thank you. Thank you, sir. So, a very good afternoon to one and all present here. I, Sachi Gandhi, would like to welcome you all to the webinar. Before we move to webinar, let me first introduce to the speaker for today. Mr. Sudhendu Lenka started working from the year 2003. He has been a trainer, an engineer, and also a physicist. He has also worked in the field of networking and SCADA security. He has worked as security trainer at Institute of Information Security, and in the span of just 2.5 years at Network Intelligence, he was promoted with the three posts that is cybersecurity analyst, senior threat analyst, and DFIR, which means digital forensic and incident response specialist, respective. Currently, he serves as manager in IT and information security at Amynasec Lab, Pune, India. His technical abilities spans a very wide range of technologies involving various security activities, not just limited to DFIR or malware analysis, threat intelligence, audits, etc., but many more. Some of his key domains are ICS, IoT, IIoT, and recently he's working with healthcare and IOMT. He is also a speaker at NULL, the Open Security Community, and the OWASP Mumbai chapter. He is not just a technology freak, but he is also crazy about cosmos, gadgets, lost history, comics, and manga. So in nutshell, he has 9 years of experience in the field of technology and has diversified knowledge about different domains. And it is said that with good experience, you achieve great knowledge. So with this good note, I would request Mr. Sudhendu Lenka to take over from here. So Mr. Lenka, over to you. Thank you.
Yeah. Thank you, Sachi. Thanks a lot for such actually your kind words. Actually, I'm not entitled for such kind words, but thank you. So yeah, I didn't start with security. To be honest, I actually started for with engineering. I started with industrial automation and robotics, and then gradually I ended up in security domain. And like on a peers and others, so they all had that. I had a knack for forensics. So and that's how I entered into forensics domain, and now venturing all everything that's interesting. So with that, I actually wanted to talk something on more basic forensics for today. But like Sachi said, so as I have been into like since last year into the hospitals and healthcare industry, so I said why not introduce this to the young masses who are so talented, so excited for this new thing. So here's my topic. uh, just let me tell that if my screen is properly visible. Yeah, is it visible properly?
Yes, sir, it
Yes,
is.
yes,
Yeah.
Yes, sir.
Okay, thanks. Yeah. So again, good afternoon all. I hope you're all doing well. um, Actually, due to some work and a couple of things, I couldn't get much time for making this really great kind of presentation. So whatever I could grab, I've just jotted down a few things, and a couple of things may not be there in my slides, so pardon in advance. And I don't want this to be a just I'm just sitting here and just talking and talking, just lecturing. I want this to be a little bit of interactive too. So if you have any kind of if you are having any kind of trouble, if you want interested something, but yeah, let's stick to some now topic. Then please do raise your questions and all, and yeah, let's start with. So coming with that, healthcare industries. I think this had been a topic since 2015 for healthcare industry and its security. It's actually started with how IoT came into the picture to the medical industries. So coming it, and then there was a term also coined like IOMT, Internet of Medical Things, and this mainly started with devices that are starting to getting interconnected with each other, not just in a particular traditional scenario that you visited a doctor. There were scanners, or there were some devices for testing your vitals or other kind of things like heart rates or so EGs, and the body scanner like MRIs. But this also moved like how uh, healthcare has been made reachable or accessible to the patients. So, but this thing what actually majorly affected places like India has been like past like 2 3 years, and but with the last year's pandemic, COVID-19 that we know, things have actually turned away. So we have seen a huge rise to various kind of malicious actors who have been not taking any breaks, unlike most of the people who we are all on breaks majorly during this pandemic situation. But they were actually on pretty much on rise. There were more crimes going on, more attacks on the medical industries, to hospitals, to vector, to other vendors, and again, I think recently many of you must have known the supply chain act attacks. So I'm going to talk about a couple of all them. Today, I'm not going to teach you how to do forensic analysis on these things. Rather, why forensics is about important on this thing, and what are the different components that we should care when we're going for forensic analysis into the healthcare industry, and couple of factors or challenges that we face. I think for more about how to do and all those things, I think that would take some other day, some a longer time. Yeah. So I think you all already know about me, small from Ms. Sachi's actually introduction. So yeah, this is basically me. I'm also known professional as sudo, they call, and anyone who is familiar with Linux, they know what sudo is. And yeah, these are my basic things and my Twitter handle. So do connect with me if you want to have some interesting chats. I'm always open for having some good talks. So yeah, please do connect with me. So before I proceed to more about things, let's talk about some couple of words. Jargons. There are more than this. There are some couple of fancy words also, which I won't be focusing too much. But let's talk about some basic jargons so that I'm not confusing when I go further ahead. So yeah. So first is like patient information management system. So just like any central management system in IT industry or in the fintech industry, how we have for businesses or any central computer IT and management system. So patient information management system that deals with all kind of electronic records dealing with patients, any kind of starting from their entry to exit, like for all scannings, their bed reports, their nurse, their diagnostics, medicines, anything. That also provides them patient entertainment systems. I'm not sure many of you are familiar, because in India we don't have, in all the hospitals we don't have patient entertainment system. But yeah, if it goes to all those big hospitals with all in posh areas with all those latest technology, yeah, you will definitely find them. Then IoTM, I have already explained about that. um, so yeah, next is I wanted to talk about DICOM. So that's digital imaging and communication in medicine, not to be confused with the DCOM, that's distributed component object model. So DCOM is also used in this field. Like it's started with something for having distributed control, like you have a software or you have a control, if you have something part of program in one part and then you have part of program in another part. So for there it started with DCOM, and that's definitely useful in hospitals. We have all connected division, different departments, different cares, different labs, all those sectors. So we will check about those things. DICOM is a major protocol that's been used for industrial protocol, that's used especially in healthcare industry. It's more of like how CT scanners. I think many of you must have seen a CT scan. So CT scans or MRIs, various all those things, imaging things, the data, those are transmitted through DICOM. Then we have PACS, that's a picture archiving and communication system. Again, that's related to like imaging and how so images are stored, how data are. So it's unlike how in IT we have all our packets and all. So a little bit different in that aspect. Then we have like our HIS, so healthcare information systems. That's similar to our patient information management system. It's just like this is that's a central hub for your patient system. HIS, they deal with anything that deal with that, may be a lab system, a central lab system, pathology lab systems, or like we have even training sections, and etc. etc. Uh, then we have to confuse the thing. One is EMR and EHR. So EMR is basically electronic medical record, and electronic health record. Both deal with patient records only. But if I have to say specifically, the difference is that I can the best understood the EMR. It's a digital version, just a digital version of, if you see the old time how the patient record was to be maintained by nurse, patient charts, their improvement all. So that is basically EMR. Just you convert the patient chart or patient health report, health chart to the digital version. And that is the main thing. The difference is like EMR is restricted to a particular clinic or hospital. It's like if you get inside a hospital, you get admitted or you get checkup, whatever data is there, that's then and there. It is not interconnected with any other organization. It is not shared across. Now in India, we don't have a detailed patient portfolio, like in not universally. We don't have certain places they do practice. We don't have a universal kind of patient record mechanism, like starting with all those whatever whole complete health history. Now EHR that does that. It starts with every health record that we have. Like if, for example, if I'm going and getting into one hospital, then I'm moving at and I'm going for diagnosis to some another hospital. Now all those records, those are jotted down in your EHR. Let me tell you, most of these things, technology, we have a concern based on the research where it started, like the US. Even I'm going to talk in the in a couple of few slides. Even the standards that are practiced in the healthcare industry, that also started with the US. So HIPAA, I think most of you have heard, but yeah, let's move ahead. So the highlighting the main change about this is like most attacks that happen, and that may not seem quite big for now, like tampering of EHR record. So that causes a huge problem, like when data are transferred across different hospitals or different medical parts. So in those cases, that's quite disturbing, because data properly is not handled, and most of the communication or medical things, they are done either clear text or simple encoding. That's easily visible. No proper encryption and all those things are maintained for most of the thing. Now is like computer-based patient record, CPR. Now again, that is similar to that, all electronic records and all. POCT, point of care testing. Now that's another protocol that deals with medical term. So it started with POC, the point of care, not to be confused with proof of concept. So the POC is with patient testing that allows various medical staff, doctors, physicians to accurately like test or achieve data in real time. So it is main about having a real type data transparency for diagnostic, for lab analysis, for results, like some results that may take for example, if you want a scan or a blood test from pathology, getting all those data from a different building or a different location. So all those things can be made with the point of care, mainly like point of care meaning near to the patient. So that's made available using this thing, from blood analyzer, pressures, everything. Now this also helps the physicians or the doctors to triage, like triaging for rapid triaging, if I have to say, how severity for the, various components or medical facilities, all those things. Then in that POCT, we have a specific protocol that is POCT 01. That is actually the protocol that's used. It's a various newer XML based protocol, and this communication protocols which actually has the XML messages that's exchanged over interface between equipment and what you call this point of care data manager. Okay, and this thing actually is and follows HL7 protocol, health level 7 application protocol. Another we have similarly to this POCT is LIS 02, that is laboratory instruments and information systems. So it is also a revision of a previous standard, that's ASTM E1394, and it was that is mainly for serial communication. Okay, so easy way to remember is like POC1 is basically your XML based messages. Um, and that's based on actual 7, and then LIS, that's more of our what do you call serial communication. Then we have HVACs systems, um, and then finally HMI. Now HMI are your panels that are for interacting with machines. They are basically your digital dashboards that help a user to communicate with a machine. So that may be a basic patient entertainment system that provides patient information, that provides basic few entertainment, relaxation musics or videos to patient or informatics to patient. They're generally available with advanced IoT environments with patient beds and all. That also helps for nurses and other to check about patient data and all. And one scary part is like all this the patient and entertainment system, they're actually connected with each other. So it's very easy to actually break into another patient's data through one patient information, through one patient's patient entertainment systems. Uh, and this HMI, it's also actually displays real-time data, so it's pretty much faster. Yeah, and yeah, so we have a couple of organizations that deal with medical security, and they provide standards and care about healthcare and all. So they are like MDIC, Medical Device Innovation Consortium, Health Information Sharing and Analysis Center, Medisao. So SAOs, they are sharing analysis, information sharing analysis organization. There are various organizations that are government and private organization that sign MOU with the respective government that provides these kind of data, like for provides information security advisories with maybe OEM products or directly anything related to medical protocols, industrial protocols, all those things. Then we have ISAC and HISAC. They are all similar kind of organizations. We have US ICS cert that is actually maintained by Department of Homeland Security. And then we have another standards that with the rise of IoT devices, they're mandatory generally to, at least in US, to adhere to this one, that is MDS2, Manufacturer Disclosure Statement for Medical Device Security. Now, another thing that's apart this is a standard that's followed, that started mainly in US and is in 90s, and now has taken over all world. Like everyone is discussing that, and they are trying to bring up their own standard for that. So that's HIPAA. That's Health Insurance Portability and Accountability Act. It was done in 1990, drafted around 1996 or something. And again, that was upgraded with all those, because that time we didn't have IOMT and all those things. Later, with it was upgraded for a high-tech act. That's Health Information Technology and Clinical Economic Health Act. So these are SDOs. SDOs are nothing but health delivery organizations. So they are basically other than a basic hospital, they are various of these kind of departments or entities that actually help in healthcare business, healthcare and medical tech business. So there are various parts inside that. For integrated hospital, they have all those SDOs with them, except the vendor part. For rest, they have the segregated thing. Like they may have one basic like physician sector, the hospital sector, and they have different labs or research areas and those pathologies, scannings, and all those things at different places. So these are a couple of things like nurse stations, sterile processing, surgery centers, patient rooms, telemedicines, HBI, patient beds and all, infusion pumps, guest access, monitoring equipment, the labs with PHI, workstation pathology. So there are a couple of these things. So sorry, medical IoT devices, they are actually dividing various kind of these things. Like certain we are seeing, like certain are monitoring part. Certain are actually like that help like life information, like heart rate, or they are oxygen sensors. I think now we all do have with miniature like an oxygen, like saturation measurement systems with us, temperature we do. So a couple of like these things. These things are there are both like conference rooms, pharmacies, data centers, security workstations, and all. So they all are connected with a data center. That may be directly or indirectly, and if you have to consider a smart hospital, that's what we call a hospital with a latest hospital with all those connected devices. When you say smart hospital, that's nothing but a hospital with all those various entities having a using connected devices. Now, the main thing that worrisome on this is like IoT is not a very what do you call say? It's not a very latest kind of thing. It's a very recent entity. And if we have to consider medical devices, like so there are these kind of healthcare devices, big hospitals, like one few of my clients, they are in a US hospital, so they even have like more than, you can say, like 20,000 devices in a single entity, and in a single hospital, not entity, sorry, in a single hospital. That all including their IT sectors, their IoT devices, whatever OT devices, operational technology sites, or any devices that exchange any kind of sensitive data, highly sensitive data or sensitive data. So they all account to this kind of thing, and these all devices, they have a quite a big potential threat section. So they are actually quite vulnerable. Many of them, they still use legacy systems to control these things. With a recent development and all, couple have them been forced to use the minimum what do you call say, minimum acceptable softwares and hardwares systems, but still many of them, they follow those legacy things. And the major thing are the protocol, the industrial protocol. They are yet to be revised with all the latest requirement and latest standards. So yeah, these are a couple of medtech protocols that we have, like HL7. I think I already talked about that. DICOM is there, and then POC1 I have said. LIS2, that's also data export and RH So data export. These are certain proprietary one, RH and data export. So data export, it's used by Philips, Philips patient monitors. And like for example, they have their Intelview series and all. So basically, even RH that is also part of patient monitor system. So that is so data export is proper to Philips, and RH is proprietary to General Electrics. And if you have to go for forensic analysis, so like how we go for an IT sector, if I have to go just snip a packet followed based on your OS layer, you just go and whatever packet wherever you want to, for L2 or L3 packets, you just capture those packets, put them into your packet analyzer, and then just check it out. Now for understanding packets, where for these protocols you need to understand whatever these protocols are. So due to lack of time, I'm not going deep into these protocols, their structures, and I think that's for another day. Yeah. This is an overview for data communication inside a medical system. This is a very very high level just communication system. I'm not gone into a very deep. So yeah, so these are like, let me just read this. Okay, so these all entities like pharmas, hospitals, clinics, vendors, STO. So they deal with EHR and EMR, and these data are again they are actually communicated over all these entities, like delivery devices, patients, for monitoring devices, instrumentation and control, alarm notification, and of course the medical staff, including the physicians, nurse, and all. So so whenever we go for these kind of communications, uh, so it is quite important to understand exactly where the issue is occurring. Like for example, if I have to consider like instrumentation and control system. Now instrumentation and control, that doesn't just have your IT environment, that is working with OT environments. And there are a couple of challenges when we deal with these kind of environments. It's not directly working with basic IoT protocols, and it's not going with following your basic TCP IP and all. So yeah, so these are a couple of things that this needs to be considered when dealing with for data communication for in the instrumentation control and the OT environment. Now, if I have to correlate these things and all, so these kind of monitoring devices, they actually what we are seeing in the medical environment. So they have various devices like for example. The patient oxygen level sensors, or providing physiological state of the patient, and and they all work on wireless body area network. Now, most of them that work on, especially the sensor that work on the wireless body area network, they have actually they can be classified into couple of like three node system. Um, so one is implant node, that is very it's closer to us. It's planted under the skin, and then we have the body surface thing, and then what do we have, the external, that's closer to our body, but like within like few centimeter kind of distance, like say 5 to 10 centimeters. So it's the three level that we divide the node. One is inside the body, one is on the skin, and another is outside the external the body. These three nodes, they comprise the WBN, so wireless body area network. Now, when dealing with wireless body area network and the data collection from them, we face couple of challenges, like for example, layer system. There are unlike your normal layer, we have object layers, we have object abstraction layers, we have then the applications layer, we have so these are a couple of layer that actually work in WBN sector for medical industry. And these can be recognized as a perception layer too. So they are for dealing with physical devices, and aim to collect for processes, and they various kind of other kind of orders from operators, or checking kind of other for clinics, or say patient kind of vital monitoring device systems, all those things. By the way, am I still audible properly, right? Hello.
Yes, yes, you are audible.
Okay, okay, thank you.
Yeah.
So like I was saying, the wireless body and network that connects these kind of independent nodes, and they can be situated in the clothes, or in the on the body, or on the skin of a person. So if you say a small kind of Fitbit bands, so they also come under these things. So they are closer to our, especially those heart rate sensors and a couple of other sensors that we have on our Fitbit bands. So they actually come under this WBN. So they are actually extra part of the external node. Why like go for DFIR in healthcare? Definitely, there are like along with all these challenges, the major thing is health market is growing huge. Let's be honest. Like whenever security and standards and everything, they are interested into something that starts with the market. The reason, like till now, the fintech industry was always prioritized was due to that. We had air gap in our critical infrastructures, so that's why security and all were not much realized there until we had a big malware attack in 2010 in Saudi. That leads to that actually opened couple of doors to security to our critical infrastructures, especially the industrial sector. And a similar case with medical. So it has been actually checked in the market that the healthcare market can rise up to 8.6 trillion. So that's almost $133.44 billion. And it was projected like in 2020, it was around 50 to 60 billion dollar. So you can say it's almost 3 times by the time we are reaching 2022. And that comes as a major section. Second, the criticality. Earlier, with less connected devices, though whatever the accidents that could happen in healthcare industries were minimal. But now with these things and with all the supply chain attacks, threat actors trying not just to mess up with patient records, but even there are cases, like criminal cases. For example, we all know that the organ donor system. So even there are threat actors that are actually try to mess up with patient records, so that even this what you call without permissions and all these kind of organ can be donated. So even things like that happen. So with all those things, digital forensics into these electronic media in the healthcare is becoming more and more important. Yeah, like I said, definitely investigation this PHI, that's the most important part. HIPAA data they has been exposed. So I will go over a small case with how even something that been passed that has been actually under the compliant under HIPAA is still vulnerable. That's with one of the protocols. We can detect how our network was breached, collect evidence. We can assist in responding to ongoing threats. Another thing is like the recent thing is making the actor profile. So right now, just not investigating or how the breach happened is not going to help. We have to go for active defense. Now, active defense actually calls for threat hunting and for actually identifying the actors that actually help for any ongoing, if there are any ongoing malicious campaign or any future potential attacks. And that also helps to identify various kind of similar kind of activities by related to the actor or their group that's already going on in the what you call dark web or dark net, so that in future these things can be protected. In one of my work, we are dealing with intelligence report for a particular hospital, and we found like even though those hospitals were not directly breached or something, but due to the supply chain or due to various other services that the hospital staff may be using, many of them were breached, and through that the threat actors, they were able to access hospital networks and then get into the hospital and do whatever their nefarious activities. So yeah, like prevent future illegal access and sharing and all. If we say the complexity of the attacks, that's also another case. Like a basic IT attack can be a very simple to a little bit complex. But if you're going for attack, not in a open this IoT device, but in a properly secured medical environment, those attacks, they are not actually quite complex. So they don't just go with attacking or directly go and reach the hospital. No, that's not always the case. They actually take the route for supply chain, or they try to plan any kind of they actually go, sometimes if they don't find anything, they will directly go find check any product, even go for the like the protocol. They even go for protocol reverse engineering, check whatever the vulnerability they have, uh, and then try to exploit it. Similar thing happened with DICOM. And even though DICOM is what do you call, it is and have been used hugely, and still it's not secure till now. So yeah, if you go for complexity of the attacks in medical industries or any of the critical infra that we go, they are complex. These are a couple of, this is some threat landscape of a basic sample of hospital environment. So if we go and see, this is our threat actor. So they have visibility, they don't have direct visibility to multiple things. But they don't have visibility to our clinical networks and all. We also have, almost nowadays, everyone has a firewall. So still, the main issue comes in the lower level. So it's not just like the top-down attack that is so they go for mainly top-down attacks, but it's not just a top layer that is going to save the day. Like once the attacker is inside the IT, like crosses the IT layer, they get into a highly vulnerable environment that is filled with outdated and legacy systems, that is filled with protocols or devices that are vulnerable by virtue, by design, by nature. They have like medical industry places. Now nobody is going to use like maintain a password manager, or maintain any kind of high security locks and all those things. So in those cases, most of them that are various hospitals, they don't actually have a security at their own place. They just hire a third party to set up various solutions, and then that's gone. Now, in those cases, we have all these default passwords, we have default configurations. That's a very, that's a cliche. Those things like sound cliche that, okay, that's in every industry we have it. But yeah, that's what the truth is. That is one of the major reasons that where the attacks occur. And if you want to actually analyze those things, then we have to maintain proper logging system, proper access control and all those things, so that like in case when there is an incident, we can capture whatever artifacts that we require related to the actors from those things. Now, if we consider these kind of systems, I think we are running low on time, so I won't get deeper into this part. So various actors involved in the incident. So I generally categorize them into three categories. One are intentional malicious ones, like we have all these threat actors to plan all the attacks and all, like hackers, or sometimes it's state-based attacks, supported by big organizations or countries level. Then we have organized crime by various groups, we have crime groups like APT groups we have. Then we have this activist or hacktivist, all those things. Some may even go for thrill and all. So they are all intentional attackers. Then we have the entities that come in the gray line. that we generally are unable to determine whether that was an accidental thing or that was an intentional attack. And then finally we have the unintentional or the accidental ones. Now, there we have sometimes, someone just like you said, like some where someone just left some place insecure, or someone just kind of messed up like while data entry, or some other kind of activities which led to which led to a series of acts that ultimately caused incidents. So those things we won't call attacks, unintentional attacks or accidental ones. Those are called incidents. Yeah. So these are kind of supply chain attackers. They are one of the major things in today's date. So there are various things like policy developer or acquisition specialist, integrators, software developers, hardware component developers, network providers, operators, user. So these are all various that you can say surface area which a threat attacker can use to actually get into the organization to launch their whole attack. Now there are various responsibilities that we need to implement, like just implementing compliance or the security standards or practices on the own organization, that's a hospital or whatever the medical facility that is not going to help. We have to go for the supply chain actors that recently if you have seen the fire case or a couple of other incident that's happening out there, so they all involved the supply chain attacks. In the supply chain, I would another say like if I have to go for another use cases that is not exactly supply chain, but that involved like DICOM. Uh, so DICOM is pretty much vulnerable, like I already said. But that's protected. Various we say the organization that are protected with HIPAA. Getting compliance. Is that enough? No. So if something that is actually uh, compliant enough is not secure enough, it's a very well-known thing. So even like we feel that like HIPAA it created a floor of cyber capabilities that was helpful for small organizations, but no, not if we go for all these smart hospitals or the larger hospitals. Now, this compliance, this is a very low bar. Like actually, I guarantee that little healthcare organizations they would do nothing without regulations. They like if it's not forced or pressure due to regulation, they won't even have this basic piece of paper properly securely in their shelf, or say locked room physical security. Forget about the default passwords and keeping patient electronic records and all those safe. So even pressures from HIPAA that interacted with that target level of cyber security capabilities. In a way, it result a non-desired level of cybersecurity capabilities, and help the hospital to focus on what it calls, I wouldn't say personally wrong things, but non-important things, and then that led to various kind of security incident. Now, yeah, HIPAA has distorted the security in the hospital. So what happened? Let me tell you one case. That was named as like HIPAA protected malware. So what happened is like there was a weakness in DICOM, and it enabled malware to infect patient data by directly inserting itself into medical imaging files. So how we know, like how to the normal image file in the headers and all, a piece of malicious code can be inserted into it, and if the image is shared and that's opened at the victim side, then the code runs and executing the whole malware chain that may connect to any kind of C2 to if even if you block those links, then it can even connect to C2, say from a Microsoft Teams channel or Slack channel, or even to a genuine like GitHub account. Now in hospital they may not have GitHub and all, but they will definitely have this Microsoft and a couple of other things open. And by connecting to these genuine domains where the command and control is there, they can again download the instruction, and like in your studies, the whole malware chain that occurs. Now these hybrid files, that the DICOM image file inserted with the malware, so they were properly executable malware binaries. And funny thing is, like, they were all compliant under HIPAA. Now, if someone just goes by that and just check with that, so these DICOM images were compliant and secured by HIPAA. So that also gave a big challenge to us. What now, because of that, those malware files could not be submitted to automatic detection systems. They were protected not to be shared to any like in the instant to be shared to any other analyst. They were no, because they were again protected by HIPAA. So they were not able to be accessed by a couple of security tools that we keep in picture to access any potential you know, uh, malicious artifacts that come along with secure documents or emails or other things. Now, by mixing in this with this particular protected health information, this malware, it easily exploited the data's clinical or the whatever regulatory implications, and they evaded all kind of detections. And until it was too late, that was not observed. Now, this vulnerability, it's actually is different from something like what you call said like vulnerability or issues by or weakness by the design flaw. But here, the clinical environment and the regulatory itself became the flaw, because due to them it was not detectable. It's not that the those files are not detectable, but due to this flaw, those files were skipped from certain security procedures. So this is how your HIPAA became what you call a challenge for say forensic analysis or the detection of the malware that was sent into in the DICOM image. So a similar thing are happening, and various kind of now the incidents are occurring with the what you call the EPHI, the PHI records, electronic PHI records, and they are being embedded into that. So we definitely need some reform and proper procedures that you can have. So before you go for any incident response to any medical organizations or any medical data, that you need to have in priority, you need to have all those permissions and everything in hand, so that your process and procedure are not obstructed. Otherwise, what will happen, you will keep on going, you will start the investigation, but you won't be able to touch those sensitive PHI documents or anything that is protected by regulatory laws. So yeah, these are a couple of challenges that we face when doing forensics in the medical things. If we go for these are all, I have just categorized based on like a network forensics or cloud forensics, legal and all. The legal factor I discussed, like this is so one of the biggest hurdle for us. Yeah, training and complexity, definitely if we are going for anything new, the training is required. We don't have many people in when you say security or infosec, people generally tend to come from IT background. They don't have knowledge for this industrial protocols, so training and awareness on those things are required. People need to understand industrial protocols that are or proprietary protocols that are being used in the medical healthcare industries. people need to understand various kind of devices like infusion pumps or continuous glucometers, those are continuously being that sends continuous data, or they need to show how the data are being stored and all those things. So these are a couple of challenges that we face in the medical, doing any forensic investigation in the medical industry. I think I will just keep it here, sweet and short. There were a lot many things I wanted to discuss, but due to time, I was just a little bit pressed. Like I had to compress a couple of things. I think let's have for some day, other day, where we can talk a more practical approach and have more things exactly what to consider, how to go, and maybe we can discuss any particular use case directly, spending a couple of times. Yeah, I think thanks. That's all from my side. Any questions?
Students, you may ask the question. Yes, what is the equivalent of HIPAA in India?
Yeah, so in India, actually, there have not been any equivalent for HIPAA. So there were a couple of acts that are actually drafted, but they're still not. So there have been some kind of amendment that are been trying to do to the IT Act. A couple of they started actually. I think there was one DCSA and another something. Sorry, I'm just forgot the name because they are all just drafts. They are still not be there in the picture. But we hope that by it, they are actually claiming that by 2022 or 2023, we'll definitely have an act for healthcare industry. Yes.
Any other questions?
Hospital administrators, definitely hospital administrator role is there. One thing is properly, for example, if an hospital administrator there is an incident and an hospital administrator they have to take proper whatever permissions and everything, so that an investigator whenever they start investigating something, so they don't have these kind of hurdles and all. Second thing, they need to enforce their own what you call say like how we have in IT industries and other industries, SCDs like secure configuration documents, or certain kind of their own regulatory document that is not more of a regulatory but actually a practice document, to and an SOP also, so that in terms of any kind of incidents or before prior incident, doctors, nurses, staff, they are properly trained with those things. So whenever we see any kind of medical staff joining industry, they don't actually go for any kind of these trainings. They just go for their whatever medical trainings and they just start working. If you see for security, now we don't have all those pure security companies also going on. Infosec is being actually mixed into all those things, like for fintech industry and all. Now how many fintech industry have you seen they actually when in the orientation or when a new joinee join, they actually do a sanity check or actually go them have them infosec class on that? No, we don't. I'm very thrilled and happy to see that even the management department here in NFSU, they're actually discussing and talking on this, because that's actually required. Because see, whenever we have any manager sitting inside, that has already been an archaic issue. If you have to consider, like if you say an industry, that's especially happen in industry. In industries, managers and engineers, they never go hand in hand, because they don't understand what engineers want to explain, and engineers can't understand various regulatory and other aspect that managers deal with. So these things need to be done in hand. And yeah, and more in that, like these are all operational things. And I believe like no matter which department you are, operational knowledge is to be garnered by each and everyone. Until unless you understand the whole operation, how a thing functions, whatever the various protocols in picture, what are the challenges that are there. So these are things won't be solved. Yeah. Any more questions?
Sachi ma'am, your mic is.
Sorry. So there is one question is that how is the healthcare industry preparing to defend against the rise of malware attacks?
This is interesting. Actually, one thing is like the case with the DICOM, which I said. So they are trying to place some different kind of protection mechanism and filtration that their regulation doesn't come into picture. Now this is, I'm not talking about the US still has all those clumsy methods. If I'm to go for like say Russia, so what they do is they have irrespective whatever the data privacy and all, kill that, they are more concerned about their security. So they have placed various kind of intel teams, like say advanced dedicated active defense mechanisms, threat hunting. So all these things while generic thing what do we have in our IT industries for preparing to this malware attacks. Now coming to specific to the if you go first cover specific to the healthcare industry. Now this is very niche field, right? And not much improvisations have been done for defending against this malware attacks. Now one thing to be understand that these industry, they are critical system and they deal with real-time information. Now we can't have something a delay of even of 1 millisecond or 2 millisecond that can hamper. Like now we are not considering, okay, you say like if a pathology lab sends a data and it is coming to the physician and it's get like 1 second delay. Now what does that matter? No, that doesn't matter. But if I'm talking about the critical care or like ICU or similar there, where we have patient vitals and other monitoring system, now there a delay of second can cost quite a lot. And we are coming with like all those automated devices, connected devices that actually work in your feedback loops and everything. So there the delays and whatever interference with any more parties and all that causes trouble. So yeah. Anything else?
Okay, so even I
Yeah.
have one question, Sudo.
Yeah.
So what kind of threats and attacks do you face regularly? Like what are the common attacks and threats you face in this industry? And how do you redeem those threats? Can you just explain if you can?
Yeah, sure. Whenever we deal with this hospital industry, so the first thing I would say, like rather than what threats we face, let me go with like what we generally do. So what it like hospital triaging. The first step is actually triaging whatever various things are there. Second thing that we deal with whatever the identifying the whole supply chain. Right, this is a new thing. Like earlier people are not much interested in that, but right now identifying the whole supply chain, and is there any lacuna in that, avoid any kind of default mechanism that's there in the hospital environment. And second third is that look, after these things, employ security vendors, accredited and properly authenticated security vendors. Get them done on a sanity check, do a DFI check. Now, many people, they think that forensic investigation or a forensic check should be done after an incident. Now, let me tell you, that is a very wrong kind of misconception. Forensic checks is just like how you do security audits for your compliance and all. Forensic audits, we call that forensic audit, but more than that, we need actually forensic investigations also, like how you do for an assessment, vulnerability assessment testing. People do pen testing and all. So similarly, we need a forensic sanity check in an environment, be it at the hospital or anywhere else. That actually gives a lot inside the picture. You can say biopsy in a hospital, biopsy of the whole environment. That actually helps with dealing with these attacks. Now, if you come to attacks part, those are all generic. You don't have any kind of, the only thing is the way the attacks are done. attacks are all similar genetic. What do you call that? Disruption of the what do you call the electronic data is there, disrupt or any kind of devices, all those things. So there is nothing any different and a unique kind of, or you can say like whenever like rocket science app, we have something done here. Even if you consider like oil industries or any other industries of operational technology, dealing with operational technology, I would say the case is same. Yeah, ransomware attack, if you consider, if you have to tell me, the one of the most critical thing in the hospital environment are the ransomware attack, because yeah, once the data is lost, that's quite critical there.
Correct, correct. And one another question is that is there any kind of specialized certifications or any other courses which are related to this basic industry, like healthcare industries, which our cyber security or any student can do in regards to this industry?
To like couple of, there are not if you have to say like exclusive certification that we have that trains you into these things, but yeah, if you see a couple of those organizations that I shared, like HISAC or NISAC, so we have even those certification bodies like SANS, they are coming up with various things, right? For critical infrastructures and all. So yeah, learning about critical infrastructure, that helps. Learning about industrial controls, dealing with healthcare industry, that helps. Certification, if you are for compliance and regulatory aspect, then yeah, knowing right now what's valid now, HIPAA, if you are getting certified for that, that actually helps. In India, we don't have any kind of regulation, so if you want to be certified for India, then sorry, there is none right now. But yeah, you can have all these things around, and all of that can closer to it for these standard organizations that deal with healthcare, like HISAC or NISAC or yeah, US cert. I believe they actually deal with certain kind of trainings and all. So trainings are available. There are a couple of trainings dealing with medical industry, but not much pure dedicated certification for that. I'm not sure. I cannot say like globally, because I'm still, I haven't seen and checked everything. So yeah, if you guys do find, please be my guest. You can ping me even on Twitter and all. But yeah, as far as I know that there aren't any major players that go dealing with these kind of certifications. Yeah.
Okay. So, and I hope there are no other questions. So, Dr. Barut, sir, are you there?
Yeah, Sachi.
Yes, sir.
Yeah,
Yes, sir.
Yes, sir.
Hello, sir.
Hello, sir. I have gone through the sessions, but practically I am not a man of computer, so your technicality is just bouncing back. But it has been the actually beneficiaries are our students, those who are pursuing their career in the field of cybersecurity management, and some are in forensic accounting also, who are basically dealing with such kind of technicalities. So thank you, sir. Thank you for sparing your time with our students and with us. And we hope to see you for more sessions. And I personally request you to help our students in such kind of practical problems which they are facing in their teaching as well as their corporate life. So
sure.
Thank you, sir. Thank you for accepting. Actually, there is some problem with my video, so I couldn't connect you through video. So that's why. Thank you, sir.
No, sir. That's absolutely fine. That's absolutely fine.
Yes.
Yeah.
Thank you, sir. Over to you, sir.
Thanks, sir.
Yes, sir. Yes. So, at the end of this webinar, I would like to express my gratitude to our Associate Dean, Dr. Haresh Barut, my colleagues and technical team, Professor Vipul Joshi, Professor Umang Jitya, and Professor Mukund Purohit, and all the other attendees present in the webinar for the presence and contribution to make this webinar successful. Last but not the least, I extend my gratitude to our speaker, Mr. Lenka, to take out time from his busy schedule to impart good knowledge of DFIR in healthcare industry, which was new area of knowledge for many of us. I am sure the people who attended the webinar must have gained good knowledge and good information about this domain. Thank you so much for sharing it with us. It was our pleasure to be part of this webinar. Thank you so much, sir.
Thanks a lot. Thanks a lot.
Thank
Maybe
you.
we can do this. Like Sir said, we can do this. I may have a couple of friends also. They may be interested in that, and yeah, we can surely
Definitely.
keep that. And yeah, like you said, if we can. And I know for these kind of like odd, like how the students are and what they are aware with,